Greetings to everyone. Welcome to week 4 of CS320 Advanced Object-Oriented Program. Today, when we first, going to get into the definitions, we're going to be concentrating on exception handling, on logging, as far as monitoring how the system is working and what kind of, if any, exceptions or errors that we're getting in the system. How do we record that and how do we log that so that we can keep informed as to the state of the system itself? So let's go ahead and get started with the overview of the definitions. Okay, so we're talking reliability, exception, and defensive design. The first one, resilient Java applications. They're programs designed to continue operating even when errors or unexpected situations occur. Those are resilient Java applications. Exception handling is a method in Java used to detect, manage, and respond to errors during program execution. Structured logging, recording program events and errors in a consistent, organized format so that they can be monitored and analyzed. Defensive design practices, programming techniques used to anticipate potential problems and prevent failures. Try catch, a Java structure used to run code that might fail and then handle an error if it occurs. For example, you're going to try the code that you think that may fail. Okay, and if that particular failure happens, here's the exception to how you want to handle the error. So it's try, catch, process. Custom exception hierarchies, creating your own exception classes that extend Java's exception system to represent specific application errors. Check exceptions, exceptions that the compiler requires you to handle. Check exceptions requires you to handle declare using throws. Okay. Unchecked expressions that occur during runtime and are not required to be declared or caught. We're not all errors need to be captured. There are such things as minor errors. Example, the null pointer exception is one of those items. Java logging framework, libraries used to record application and activity errors and system events. Java util logging, a Java built-in logging framework used to create structured log messages. Try with resources, a Java feature that automatically closes resources such as files or databases connections after use. I'll give an example here. We did a read on a file.txt file. After our processing ends, Java will automatically close that file. Even though we could have the capability to close it, Java will automatically do that for us. Isolate failure within models, designing software so that errors in one component won't crash the entire system. Recovery paths, alternate actions a program can take after encountering an error. I'm going to specify what those paths are. Fallback strategies, backup solutions used when the primary operation fails. For example, using cached data if a database request fails. Common exception handling mistakes, empty cache blocks that ignore errors instead of handling them. I got an error, but I didn't do a catch blocks for it. And so, example here, I didn't catch the exception, so I let it go. Exception swallowing, catching an exception by doing nothing meaningful with it. Swallowing the exception. Overbroad catches, catching very general exceptions like exception instead of handling specific errors. There's both sides of that. One is that we didn't collect errors that we should have, and the other is we're collecting errors we don't need to. So we have to find that balance as to exactly which exceptions are good and which exceptions that we can let go. And refactoring, writing code to improve structure, readability, and reliability without changing behavior. Rewriting code. Okay. Okay, so that's the kind of introduction to the definitions. Excuse me. So here, as far as the lecture for week 4, at this point, okay, we've talked about commandlets and execution processes, variables and pipelines, conditionals and loops, functions and modular scripting, and file input and output. Okay, now we're going to be jumping into the scripts and how they interact with real world components. So we're going to be talking about services and processes and event logs and fire rules and user accounts and file integrity hashes. Okay, this is where automation becomes operational, where we're actually doing something, not only writing it, but using it in the real world. Okay, so part 1, managing service and process. Okay, a Windows service is a background process that supports system function. Notice this background. It's not in the foreground, but it's a background process that runs standalone in the background to where we can't see it. Examples, any kind of Windows update, the print spooler, the security services, all those are examples of background processes. Okay, to list the services, we have get service. Okay, that will basically list all the services that are currently in the system. They'll either be in a state of running or a state of stopped. So here we're getting a service, and what we want is a service where the status of that service is running. Status property, filtering within the pipeline. Okay, now show stop services, same execute as far as syntax, but we're looking for statuses that are stopped. So here we're looking for services that are running. Here we're looking for services that are stopped. Okay, so here where we start service, the name spooler. Here we're stopping a service where the name is spooler. Okay, so this is start service, stop service. Never stop service casually in production environments. You'll hear us basically kind of pushing that for you several times during this week. If you don't know what a particular piece of code is doing, don't run it. Okay, it's in production. Now in tests or acceptance, you might be able to get away with that, but don't do that in production. So it says never stop services casually on production systems. List process. So here we're saying you get process. We'll basically get a stream of all the processes that are basically running in the system. Sort CPU. Once we get the process, here's where we have a pipeline. We're going to get the process. Those processes are going to go into sorting object by CPU. CPU usage descending. Killer process, demonstrating only safe examples. Stop process. Here, for example, we're stopping the notepad process. We're giving it a specific name of which process we want to stop. Okay, automation can stop critical processes. Okay, always validate before executing destructive actions. Kill, drop, stop. Okay, those type of verbs or actions that we might want to take on a process. Okay, event logs. Event logs are essential to system monitoring, security, and security auditing. Older methods, get event log. And here we're saying, give me the log name of system and give me the 10 newest events that have happened. In newer systems, here we're doing a get when event. We're getting the log name system, and we want the maximum of 10 events. So 2 different ways both of these work. Okay, this is the older, okay, and this is the newer. Okay. Okay. Filtering for errors. Here we're getting we're getting the events. We're getting a log name. We want anything that's related to system, and we want those where the object, the level display name is equal to error. Okay, so we're looking for events that have had errors. So we'll be getting those events being brought back to us. In this particular case, we only want the first 10. Okay, so level display name property. Okay, why error monitoring matters. Okay, here's the level display name. Okay, and that will contain whether there's an error or not. Okay, examples. If I wanted to count the errors here, I'm creating a collection and I'm getting the events, and I want to know anywhere that I'm getting the name error. And then once I get an error, I'm going to count it. But I'm going to be basically putting the identification for that object in here in this collection for errors. Event logs are often the first place you want to investigate if something happens. If I had a system failure, if I had a login failure, system crash, malware detection, that will most likely go to the event log to see what has and has not happened within the system. We've all heard the term of firewalls. So firewalls are basically these are where maybe something was trying to get into the system through the firewall, or the firewall blocked a unauthorized user or an attempted user. That's what we're basically describing here. We're going to get the net firewall rule. Okay, so we're getting the firewall rule, and we're saying any object. Okay, that basically violated the firewall rule. Okay, if it's enabled, okay, we say it's true. So that particular object, okay, is basically true that it is adhering to the firewall rule. Okay, enabled property, direction, inbound or outbound. These are the parameters we can select to additional select criteria that we can basically get those type of events that had either been flagged as enabled for the firewall rule, or later on you'll see where we actually violated the firewall rule. So that's what's described here. Other select criteria we can look related to firewall information. For here, we can get the local user, okay, who the local user is for the particular laptop or server. So here we're getting a local user where they have not been enabled. I have a user that's out there and they have not been enabled. Here I'm enabling is equal to false. So that basically that user is not valid. Okay, inactive accounts are security risks. Automation allows regular account audits. And again, basically we're doing this to basically see, are there anything out there that's not enabled that should be? Have I had errors where I shouldn't have errors? Here is where we're basically doing the basic auditing tools being supplied to us by, again, making sure the user is enabled, the account is active. Automation allows for regular account audits. Permissions, okay, ACLs, okay, ACLs. If we look down here, access control lists. Okay, so we now have permission for ACLs. We're going to choose the file. So here we're going to say get ACLs. And so we're asking for the access control list, who's on it, who tried to get on it. To explain, we access the control list. We have file system rights. We have identified references. Okay, this is information, again, we can either use it by criteria or that we can put on reporting, okay, to support the ACLs. So ACLs can determine who can read, who can write, who can execute, who can modify. Okay. That access control list is the source of where we're going to go to see who can do what, okay, in the system. Okay, file integrity checking. Okay, if a file changes if the file changes unexpectedly, then that can indicate either malware we've got infected, unauthorized modification, or configuration drift. Okay, I've been doing configurations to the system, and each time I did it, I was doing something wrong. So, in basically doing those configurations, we might have changed something that we shouldn't have changed or didn't mean to change. Okay, in making those configurations. The way that we determine whether a file has changed, whether file integrity has happened, is we generate a hash. Okay. If you get a chance and you have not taken, take the cryptography course where we talk about how we basically can tell whether a file is changed by determining whether the hash function for the file is the same. Once we create a file, we hash it. The hash value doesn't change as long as the file doesn't change. Any change, even 1 byte or 1 bit of the file being changed, we generate a new hash function. This is one of the things from SHA-256. So basically, we're taking those hash functions and we're analyzing them periodically to determine whether something has changed in the file. So that's what we're doing here to determine and keep file integrity. A file should not have changed or updated invalid. We shouldn't want to we're checking to make sure invalid changes have not been made to the file. No, not invalid, or any change for that matter. Now, it might be that when we change a file, we actually wanted to do that. So what we'll do is once we change the file, we'll hash it, and now we have a new starting hash value. Well, we're basically talking here, fingerprint of the file. Okay, modify file slightly, rerun the hash. That's basically what I just went through. Combining into an audit script. Okay, here, again, not really looking for you to know the exact sequence or syntax, but what I am looking for you is basically here what it's doing and how you maybe can use it later. You're creating a collection of running services. We're going to get the service, and we're going to look for any service with the status of running. And so we're going to put those into a collection for running services. You can always come back and figure out the syntax. Excuse me. Okay. Error events. Okay, here we're getting the events, and we're looking for all objects where the display name is equal to error. And we're basically putting those errors into an event list or collection. Firewall rules, we're getting the firewall rules, we're getting objects where a particular object is enabled, okay, in order to get through the firewall. Okay, that's enabled to go through. So we have, running services, error events, firewall rules. Running services here, we're going to write that out to an audit.txt report. Here's our out file. So this here, we're accumulating them. Here we're taking and actually putting them on the file. Anywhere you see a pin means we're appending to the end of the file and not overlaying the contents. So that's being explained here. So collection of system data, filters results, write summaries to the file. Okay, responsibility and risk. This week introduces real power. Scripts now interact with services, accounts, security settings, system files. Automation and mistakes. You can disable critical services like how users run open firewall ports, and delete important files. Again, that's why we need to be careful when we're doing destructive type activity or changing type activity. We're disabling, we're locking, we're dropping, okay, we're deleting. Okay, anytime we're doing that, we need to be extremely careful. Best practices, test scripts in a safe environment. That's either in a test environment or an acceptance environment. Not a good idea to do that in production. Avoid destructive commands and loops. Avoid, destructive commands anywhere if that's not your intention of doing. Okay, so next we'll be talking about debugging background jobs, scheduling tasks, where we'll be basically putting in more reliability, fault tolerance, production ready, especially in the case of scheduling where we want to run a particular uh, function, at certain times during the day in the future or at 2 o'clock every day. So this is basically that next step in being able to schedule various services. Okay, we went through the definitions, and here's was the overview for week 4 in talking about logging and exceptions and firewalls and errors and capturing that information to get the general health of the system. Okay, so I'm expecting that you will look at this before our regular in class meeting, where we'll kind of go a little more deeper dive into these. So thank you, and we will see you no later than when we start talking about week 5. Everyone have a good one. Bye.